작은 가방에도 쏙 들어가고 주머니에도 들어가는 통역기가 있다고. 아이플라이텍 AI.
Take a look at the function, the natural log function first. I'm pretty familiar with this, but explore a little bit. If f is defined as ln x, you can take the first derivative, and that would become 1 over x. Now, this kind of tells you that this is not going to be 0, therefore, this is going to be my whatever. We're just going to apply the definition, right? The definition says, okay, if you have we to the t, then it's just going to be t, all right? So we're applying it to negative x, e to the negative x. So this is my t. So that's going to give me negative x on the left-hand side. And on the right-hand side, this is going to be my whatever. And the answer is going to be negative 1. But if negative x is negative 1, that means x is equal to 1. Make sense? Okay, so is that the only answer? Let's go ahead and take a look at it from a graphical, little bit of calculus perspective. Okay, so let's take a look at the function, the natural log function first. I'm pretty sure you're familiar with this, but let's explore a little bit. If f of x is defined as ln x, then we can take the first derivative, and that would become 1 over x. Now, this kind of tells you that this is not going to be 0, therefore, no max or min, right? There's no extrema on this function. But let's go ahead and take a look at the second derivative too, because it's also interesting. It can be sometimes interesting. And remember, the second derivative gives you concavity, right? So if the second derivative is positive on a certain interval, our graph is going to be concave down. By the way, concave down doesn't necessarily mean the graph is increasing. It could be decreasing as well. But it just means that it's opening up. Like a parabola, y equals x squared is a good example, right? It's concave up because if you take the second derivative, you're going to get a positive number. So it's always concave up. And this function is also always concave up because negative 1 over x squared is always less than 0. It can't be 0. It's always negative. Therefore, f is concave down. It's down because the second derivative is negative. Make sense? Great. So another thing that you can look at is how does this interact with x minus 1? Well, x minus 1, let's call that g of x. It's just a linear function. So it has a slope of 1. And if you graph it, and I'll show you a graph in a little bit, but it's going to have an x-intercept of 1 and y-intercept of negative 1. So it's going to look like this, right? I mean, not dotted line, but just wanted to show you. So our ln function, if you set f of x equal to 0, you're also going to get x equals 1. Interesting. G of 1 and f of 1 are equal because they're both equal to 0, which means there seems to be an intersection point. Of course, we already found it, right? But is that the only intersection point? That's a good question. So if our line goes like this and our ln function goes like something like this, I'm just making it up, obviously you're going to see two intersection points. But remember, we just saw that our function is concave down. But does that mean there's going to be only one solution? Because we could have something like this, right? Think about it. Like we could have a graph like this. It all depends on how it behaves, right? But here's the thing. Something interesting happens here. Not only that they intersect, but they intersect in a special way. Because if you look at the first derivative of ln x, which is 1 over x, you can realize at 1, this is 1. So that means the tangent drawn to ln x at x equals 1 has a slope of 1. But at the same time, that this line that intersects the graph has the same slope. So those two lines are parallel, but they go through the same point. Therefore, they have to, what is that word? Overlap. Okay, there you go. So x equals 1 is going to be a tangent or point of tangency. In other words, here's what the graph looks like. I think that's going to say it better. And this brings us to the end of the video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.
비트랩을 이용하면서 3,000번씩 구하고
엘리트들은 이런 사고를 한다?
CD is C and